Great, so let's start our second to last section here. And this one isn't going to have anything new. It's going to take all of the factoring methods that we've talked about and kind of summarize them, and then we'll go through some examples and try to figure out when to use which method. So first thing I'm going to do is list out the steps for factoring. So the first thing you always want to do, no matter how many terms you have, what kind of factoring you're going to be doing, always factor out the GCF first. This is really important. If you don't do it in the beginning, in order to be completely factored, you will have to do it at the end, but a lot of the time it's really easy to forget to do that. So always do that first. That way you're working with smaller numbers and variables as well. And then we got into our different types of factoring depending on how many terms we have. So the maximum number of terms we're going to factor with is 4 terms. Notice how none of the factoring techniques use more than 4 terms. So we're not going to actually factor anything if it has 5 or 6 terms in it or more. If we have 4 terms, remember we're going to factor by grouping. And then if we have 3 terms, we'll work our way down to 2. This one has 2 different cases, but in either case, we're going to use the big X. And if you don't want to use the big X, that's fine. I think it's just a good way to kind of remember what you're going to be doing with your terms. Once you have your big X set up, we have the 2 different cases where the leading coefficient, and let me write this a slightly different way. We have the case where we have x squared plus bx plus c. So the number in front of that x squared is 1. And then we have the case where we have ax squared plus bx plus c. And so if we have just x squared, remember we use our big X, find our 2 numbers, and then we can go straight to our 2 sets of parentheses. It'll be x, x, and then whatever numbers you have go there, or different variables depending on what we're looking at. If we have a leading coefficient here that is not 1, this is what we saw in the last section, or the second to last, 6.3. We want to split the middle term. And then once that middle term becomes 2 terms, then we can factor by grouping. All right, and then finally, our last case is where we have 2 terms. And we saw 2 of these cases. We have the case where we have the difference of perfect squares. And remember, it has to be the difference if we're looking at perfect squares, like an x squared, x to the 4th, or 16, 9, 25, those perfect square numbers. And then if we have those difference of perfect squares, then we're going to take them. So we'll say x squared minus y squared, and that's going to become the square root of each of them, x minus y, and then x plus y. All right, the other case, and this one doesn't come up a whole lot. This one is if we have the sum or the difference of perfect cubes or cubes. And so again, we have 2 different cases here. We have the sum and the difference. So the sum and the difference, the only difference is the signs in the factoring. So for x cubed plus y cubed, remember we get rid of the cube, so it's going to be x plus y. And then we're going to have our trinomial, x times itself, so x squared minus x times y plus y times itself, which is y squared. And now for the difference of cubes, x cubed minus y cubed, we're going to have the same exact terms, but we're going to change two of the signs. So we're going to have x minus y, and then x squared plus xy plus y squared. All right, so those are the different cases we saw. We did also see perfect square trinomials, but because those are trinomials, those are three terms, those are ones that you can always just do using this big X method, so I didn't include them in here. All right, so let's go ahead and look at some examples. So it's just going to be a big summary of all of the types of factoring we've seen. And so we're just told to factor. So we have to know what type of factoring we have to do. So we're going to go through these steps up here. Always check for the greatest common factor first. You're not always going to have to do that. Or factor one out because there might not be one. And then we're going to go based on how many terms we have. So let's go ahead and try 8x squared minus 80x. So again, first thing we want to do here is check for a greatest common factor, which we do have. We can take an 8 out of both of these and an x. We'll write what's left and then see if we can do anything else. So this first term, we get rid of the 8. We're left with a single x. Minus 80 divided by 8 is 10. We got rid of the x. And now the only thing that we could do here, or that we just did, was take out that greatest common factor. That's all we can do because this x minus 10 is a two-term polynomial. It's a binomial, but it's not perfect squares or perfect cubes. So this is our factored form. All right, let's try another one. 36x squared minus 25y squared. All right, so let's take a look at this first for greatest common factor. 36 and 25 don't share any factors, and we have an x and a y. They're different variables, so we can't take anything out. Now we need to figure out, do we have 4 terms, 3 terms, or 2 terms? Well, we have 2 terms, and do we have perfect squares or perfect cubes? Perfect squares have even exponents and perfect square numbers. So we can go ahead and split this up into our 2 parentheses straight away. Figure out what times itself gives us 36x squared. Well, 6 times 6 is 36. X times x is x squared. And then we're going to have a plus and a minus. And then for our last term, 25 is 5 times 5. And y squared is y times y. So perfect squares, you should always have the same terms in your binomials here, just with an opposite sign in between. All right, let's go ahead and try another one. Let's go ahead and do t squared plus 4t minus 12. So again, let's go ahead and check for greatest common factors. They don't all have a t and they don't all have a number we can pull out, so there isn't a greatest common factor here. So now we have 3 terms, think big X. There isn't a number in front of those, in front of the t squared. So we're going to be able to go straight to the parentheses, but we need to figure out our 2 numbers. So we're multiplying to a negative 12, adding up to a 4. If we go through the different factors of 12, we have 1 and 12, 2 and 6, 3 and 4. Because we need a positive and a negative, we're going to have 2 and 6 because they have a difference of 4, and the 2 will be negative. So because it's a t squared, we need t times t, and then minus 2 and plus 6. don't forget the shortcut. You still can do this using the splitting the middle term, just takes a lot longer. So if you remember the shortcut, just with this case where you don't have a number in front of the first term there, it's going to be really helpful. Okay, let's go ahead and try another one. 3r to the 8th plus 24r to the 7th plus 36r to the 6th. All right, so first thing to notice here is that for one, all of our exponents are really big. So anytime that happens, you can usually factor out a greatest common factor, which we can. So we can take out a 3 from all of these and an r to the 6. Now, if we do that, remember to leave that in front. Our first term is left with an r squared plus 8r to the first, or just 8r, plus 12, and we took out all those r's. And now we're not quite done. We have this greatest common factor in front, but you want to make sure that you're not able to factor this trinomial here. So trinomial, big X, multiplying to 12, adding up to 8. Now, if we look back up here at our factors, 2 and 6 are going to add up to 8. Oops. So we can factor this, and it's that nice shortcut. So let's go ahead and put this 3r to the 6th in the front, our 2 sets of parentheses, and then we're going to have r plus 2 and r plus 6. All right. Let's go ahead and factor 8t squared minus 13t plus 5. All right. So greatest common factor first. 8, 13, and 5, they don't all have a t. There's no greatest common factor to take out. So now we have 3 terms, means big X. For this one, be careful. We're going to be multiplying to 8 times 5. Remember, you have to multiply the first and the last. So we're multiplying to 40, adding up to negative 13. And I don't think we saw an example like this in the notes before, but we're multiplying to a positive, adding to a negative, which means we need 2 negative numbers. So we have 1 and 40, 2 and 20, 4 and 10, and then 5 and 8. So we need a negative 5 and negative 8. And now remember, for this one, you can't just use the shortcut because we have a number in front of that t squared. So we need to go ahead and split the middle term, leave the 8t squared. Doesn't matter what order we put these in. I'll put minus 5t minus 8t plus 5. And then we group. And remember right here, I'm going to change this to a plus negative 8, just so we keep that plus sign in the middle. And now I'm going to factor out from each. So in this first group here, all I can do is factor out a t. We're left with 8t minus 5. And now be careful in this next one. They don't have a greatest common factor besides 1, but because we start with a negative, we want to take out a negative. So let's factor out a negative 1, which is going to change our signs. Negative 8 over negative 1 is positive 8t. 5 divided by negative 1 is negative 5. And then finally, let's go ahead and factor out that 8t minus 5. And we're left with t minus 1. Okay, let's go ahead and try just a few more here. Let's go ahead and do this one. Number 6. X squared minus 144. All right, so this one here, we have two terms. They don't have a greatest common factor, but because we have two terms, we either have perfect squares or perfect cubes. We have an x squared, so we have perfect squares along with the 144. So perfect squares, we're going to set up our two sets of parentheses, figure out what times itself gives us each of these terms. X squared comes from x times x. 144 comes from 12 times 12. And then let's put our plus and minus. Those ones are really nice. If you can identify those perfect squares pretty quickly, the factoring is usually really nice for those. All right, we'll just do two more examples here. Let's go ahead and do 3. Let's go ahead and skip this one actually. We'll do one more example. That one was really similar to one we already did. Let's go ahead and do 5a cubed plus 5a squared b minus ab squared minus b cubed. All right, so let's check for greatest common factor first. We don't have a 5 in all of these. There's only an a in the first 3 terms. There's only a b in the last 3. So there's no greatest common factor that we can take out. So now let's look at how many terms we have. We have 1, 2, 3, 4 terms. And so 4 terms means we want to group. So let's go ahead and group our first 2 terms. It's a negative, so I'm going to change this to plus the opposite. Throw in the parenthesis there. And now let's factor out from each group. Our first group, we can take out a 5. We can take out 2 a's, so an a squared, but we can't take out a b because that's only in the second term. So our first term, we got rid of the 5. We got rid of 2 a's. We're left with a 1a. Plus, got rid of the 5, got rid of 2 a's, and so we're only left with that b. So a plus b. Remember, always double check as you're going. Just kind of distribute that back in. Make sure you get what you started with. And now our second group here, we don't have an a in both. We can take out a b squared. And we start with a negative, so we'll take out a negative b squared. If not, our signs won't match. So just be careful, a negative over a negative is a positive, and we're left with an a. Again, negative over a negative is a positive, and we're left with a single b. Be really careful with those signs. All right, so final step here, let's go ahead and factor out this a plus b. And we're left with 5a squared minus b squared. All right, so those are all of our factoring methods. Big thing is being first able to take out the greatest common factor. Once you do that, if you can identify the number of terms that you have, it's going to narrow down the different options you have for factoring. It's going to make it a little bit easier. So greatest common factor, and then figure out how many terms you have to figure out how you need to factor it. So our next time, our last section we're going to be covering is going to be solving something called quadratic equations. So it's going to be equations that have an x squared in them. And we're going to have to use factoring for that. So that'll be our last section.